The most significant piece of evidence that we have in this entire ancient astronaut puzzle is Puma Punku in the highland of Bolivia.
For generations, Puma Punku has stood as one of archaeology's greatest unsolved mysteries. High on Bolivia's windswept altiplano, surrounded by endless plains and snow-capped peaks, lie the shattered remains of a monument that seems to challenge everything we think we know about the ancient world. Massive stone blocks weighing more than 100 tons are scattered across the landscape as though an unimaginable force ripped apart a once perfect structure. For decades, archaeologists, engineers, and historians have debated the same questions. Who built Puma Punku? What did this extraordinary complex originally look like? And how did an ancient civilization shape stones with a level of precision that still amazes modern engineers? Every new expedition has uncovered another clue, yet every answer seems to create an even bigger mystery. Today, that mystery is entering a completely new chapter. Instead of relying only on excavation tools and handwritten field notes, researchers are turning to technologies that didn't exist even a generation ago. High-resolution 3D laser scanners, microscopic material analysis, digital modeling, and advanced imaging techniques are allowing scientists to examine every crack, groove, and polished surface with astonishing precision. Hidden inside these ancient stones are details invisible to the naked eye, details that are forcing experts to re-examine long-held assumptions about Puma Punku and the civilization that created it. Some researchers believe these discoveries could fundamentally change how we understand one of South America's most remarkable archaeological sites. More than 12,000 feet above sea level, where the thin mountain air makes every step a challenge, Puma Punku continues to dominate the Bolivian altiplano. At first glance, the ruins appear chaotic, with enormous sandstone and andesite blocks lying scattered across the ground. But as archaeologists began measuring the stones, a remarkable pattern emerged. Many of the joints fit together with astonishing precision, in some places leaving gaps measuring less than a single millimeter. Even after approximately 1,500 years of earthquakes, freezing temperatures, relentless winds, and centuries of erosion, the surfaces remain extraordinarily smooth. Local guides often repeat an old saying that not even a razor blade can fit between certain joints. While that description has become part of the site's legend, the remarkable precision of many surviving stone connections is well documented and continues to impress researchers who examine them firsthand. Yet the monument we see today represents only a fraction of its original form. Much of Puma Punku's greatest destruction came not from nature, but from people. During the late 19th century, as railway construction expanded across Bolivia, many of the site's enormous stone blocks were blasted apart with dynamite, dragged away, and reused as construction material for bridges, roads, and railroad foundations. Contemporary eyewitnesses described workers prying apart carefully fitted stones, smashing decorated surfaces, and dismantling sections of the ancient monument simply because the stone was convenient to reuse. What had survived centuries of natural weathering was devastated within only a few decades. The carefully planned architecture became a field of broken fragments, leaving modern archaeologists with one of the world's most difficult archaeological puzzles. Despite that destruction, the surviving stones continue to reveal extraordinary craftsmanship. Among the most famous are the distinctive H-shaped andesite blocks, whose perfectly straight edges, parallel grooves, right angles, and precisely cut sockets appear remarkably consistent from one stone to another. Many researchers believe these blocks formed part of an advanced interlocking architectural system rather than serving as isolated decorative pieces. Their precision has sparked decades of debate, because the known bronze and stone tools associated with the Tiwanaku culture seem difficult to reconcile with such remarkably consistent stonework. Whether this precision resulted from exceptional craftsmanship, construction techniques that are not yet fully understood, or methods that have been lost over time, remains one of the central questions surrounding Puma Punku. Adding another layer of mystery are the oral traditions preserved by local Aymara communities. For generations, stories have described builders working with stones that seemed almost soft, shaping them before they hardened into solid rock. Similar legends appear in later Andean traditions, inspiring speculation that ancient builders possessed techniques now forgotten. Archaeologists generally regard these stories as cultural traditions rather than historical evidence, yet they continue to fascinate both researchers and visitors because they reflect the sense of wonder these monuments have inspired for centuries. Whether symbolic or rooted in distant memories, these legends remind us that Puma Punku has always occupied a unique place in the imagination of the people who have lived beside it. Today, more than 15 centuries after its construction, the greatest mystery of Puma Punku remains unanswered. How did its builders create such remarkably accurate joints, such perfectly balanced geometry, and such sophisticated architectural design without iron tools, steel machinery, or modern engineering equipment? Every fractured block scattered across this ancient plateau still carries part of that story. As scientists continue scanning, measuring, and reconstructing the ruins with increasingly advanced technology, Puma Punku refuses to surrender all of its secrets. Instead, each new discovery brings us closer to understanding one of humanity's most extraordinary engineering achievements, while reminding us that the ancient world may have been far more sophisticated than we once imagined. The deeper researchers explored Puma Punku, the more they realized that the site was far more than a collection of massive stone blocks scattered across the Bolivian plateau. Beneath the apparent chaos was evidence of remarkable planning. Every measurement, every surviving joint, and every carved surface pointed toward a carefully engineered architectural system rather than a random arrangement of megaliths. What initially appeared to be broken ruins slowly revealed itself as the remains of a structure built according to precise geometric principles. Archaeologists began to recognize repeating dimensions, consistent proportions, and carefully calculated alignments that suggested the builders were following a detailed construction plan. Puma Punku was no longer simply an archaeological mystery. It had become an engineering mystery. Among the most extraordinary discoveries were the famous H-shaped andesite blocks that have become the defining symbol of Puma Punku. Hundreds of these stones share nearly identical proportions, with crisp right angles, parallel grooves, recessed channels, and projecting tabs cut with astonishing consistency. Researchers noticed that many of these features appear to function like interlocking joints, allowing neighboring blocks to connect with exceptional stability. Rather than serving as decorative carvings, the grooves and projections seem to have been designed as structural components that distributed weight throughout the monument. Even after roughly 15 centuries of earthquakes, seasonal flooding, powerful winds, and human destruction, many surviving joints still demonstrate an extraordinary level of precision. In several locations, the gaps between adjoining stones measure less than a single millimeter, a tolerance that continues to impress engineers accustomed to modern construction techniques. As detailed surveys expanded across the site, another layer of sophistication began to emerge. Modern engineers comparing the stonework with contemporary manufacturing methods noted the remarkable consistency of the carved surfaces. Right angles remain uniform across multiple faces. Parallel channels maintain nearly identical depths. Matching grooves align with surprising accuracy from one block to another, creating the impression that every stone belonged to a much larger architectural system. Although the builders relied on the tools available to them in their own time, The finished results display a degree of regularity that continues to inspire debate about the techniques they employed. Rather than relying on improvisation, the evidence suggests that the monument was constructed according to carefully repeated measurements and standardized design principles. Excavations also revealed that Puma Punku's sophistication extended far below the visible ruins. Hidden beneath the scattered blocks were enormous sandstone foundation slabs, some measuring more than 26 feet in length and weighing well over 100 tons. These were not simply placed on the ground. Archaeologists found evidence that many foundation stones had been carefully leveled, positioned, and integrated into an organized base designed to support the tremendous weight of the monument above. In several areas, tongue and groove connections and carefully fitted locking features appear to have helped stabilize the structure, distributing loads across the platform while reducing movement during earthquakes and seasonal shifts in the surrounding soil. For a monument built on the earthquake-prone Altiplano, this represents an impressive understanding of structural stability and long-term durability. Another remarkable discovery involved the use of metal clamps to reinforce the stonework. Archaeologists identified narrow channels carved between adjoining blocks, where bronze, eye-shaped staples once secured neighboring stones together. Metallurgical analysis has shown that these clamps were cast using copper-based alloys containing tin and, in some cases, traces of arsenic, elements known to improve hardness and resistance to corrosion. The clamps were poured directly into carefully prepared sockets before being hammered into place, creating strong mechanical connections between individual blocks. These findings demonstrate that the builders of Puma Punku were not only accomplished stoneworkers, but also highly skilled metallurgists capable of producing sophisticated metal components that complemented their architectural designs. Taken together, the massive sandstone foundations, the precisely carved andesite blocks, and the carefully engineered metal fasteners formed a remarkably integrated construction system. Each material performed a specific role. The enormous foundation stones provided stability. The interlocking andesite blocks distributed structural loads throughout the monument. The bronze clamps strengthened critical joints while helping maintain alignment. Instead of allowing enormous weights to concentrate at isolated points, the entire structure appears to have spread stress through a carefully balanced network of interconnected elements. Modern structural engineers recognize the same principle today when designing buildings capable of withstanding earthquakes and other natural forces. Whether by experience, observation, or generations of accumulated knowledge, the builders of Puma Punku developed solutions that continue to impress specialists more than 15 centuries later. As digital models of the monument became increasingly accurate, researchers were finally able to test many of these engineering ideas virtually. Computer reconstructions showed that the surviving blocks were not isolated masterpieces, but components of a coordinated architectural system in which every groove, socket, projection, and channel contributed to the monument's overall stability. What once appeared to be decorative details increasingly revealed themselves as functional design elements. The builders were not simply carving impressive stones. They were creating an integrated structure in which geometry, materials, and engineering worked together with remarkable efficiency. For many archaeologists and engineers, this realization has transformed Puma Punku from an ancient ceremonial site into one of the most technically sophisticated architectural achievements of the pre-Columbian Americas, a monument whose remarkable precision continues to challenge modern assumptions about the capabilities of ancient civilizations. Digital reconstruction. For more than 100 years, Puma Punku challenged not only archaeologists, but also the imagination itself. Every visitor who stood among its scattered stones tried to picture the monument as it had once existed. Yet no one could confidently reconstruct the original design. The enormous blocks lay overturned, broken, and displaced across the Altiplano like the scattered pages of a history book whose most important chapters had been torn away. Since much of the site had been damaged or dismantled during the 19th century, researchers were left with only fragments of a much larger puzzle. Every expedition produced new measurements and fresh theories, but without knowing exactly where each stone originally belonged, every reconstruction remained little more than an educated guess. As one archaeologist famously remarked, "No one truly knows who first built Puma Punku, or exactly what the monument originally looked like." That uncertainty transformed the site into one of archaeology's greatest unsolved architectural mysteries. Everything began to change with the arrival of digital archaeology. Instead of relying solely on measuring tapes, sketches, and photographs, research teams introduced technologies capable of recording the monument with extraordinary precision. Drones flew systematic survey patterns above the ruins, capturing thousands of overlapping aerial photographs. Terrestrial LiDAR scanners swept invisible laser beams across every exposed surface, measuring millions of individual points in three-dimensional space. Millimeter-accurate cameras documented every crack, every groove, every weathered edge, and every surviving carving. What once appeared to be a chaotic field of broken stones slowly evolved into an enormous digital archive. One by one, each block was transformed into a detailed three-dimensional model, until researchers had created an almost complete virtual twin of Puma Punku. For the first time in history, scientists could examine the monument from every angle without moving a single stone. One of the earliest breakthroughs came in 2018, when archaeologist Alexei Vranich and his colleagues at the University of California, Berkeley, began experimenting with detailed digital scans of the surviving blocks. Rather than attempting to reconstruct the monument entirely on a computer screen, they produced accurate miniature replicas that could be physically assembled like an enormous three-dimensional puzzle. As researchers carefully tested different combinations, something remarkable began to emerge. Many of the stones locked together naturally, their joints, grooves, and angles aligning with astonishing precision. What had once appeared to be isolated blocks suddenly revealed themselves as parts of a carefully organized architectural system. The experiment demonstrated that the builders had not carved each stone independently. Instead, they had followed a consistent geometric language in which dimensions, proportions, and connections repeated throughout the monument with extraordinary regularity. Building on those early discoveries, later projects expanded the investigation to an unprecedented scale. By 2024, researchers working with the Idea Lab and the Tiwanaku Heritage Project combined drone photogrammetry with terrestrial LiDAR scanning to create the most detailed digital survey of Puma Punku ever attempted. Every visible surface was recorded from multiple viewpoints, producing billions of measurement points that could be assembled into an exceptionally accurate three-dimensional dataset. The precision was remarkable. In many cases, alignment errors measured only a few millimeters, approaching the tolerances expected from modern industrial manufacturing. This level of accuracy allowed researchers to examine relationships between stones that would have been almost impossible to detect using traditional archaeological methods. With this digital model complete, scientists could perform experiments that would never be possible at the actual archaeological site. Computer simulations allowed individual blocks to be lifted, rotated, repositioned, and tested without risking damage to the original monument. Using gravity-based simulations, researchers allowed the virtual stones to settle naturally into stable positions. Again and again, many of the H-shaped blocks and adjoining architectural elements fit together in ways that distributed weight efficiently, while creating remarkably stable structural connections. Rather than functioning as isolated decorative pieces, the stones behaved as components of a carefully planned modular construction system. Every groove, projection, socket, and channel appeared to serve a structural purpose within the monument's overall design. The investigation did not stop with geometry alone. Researchers also introduced machine learning algorithms capable of examining thousands of measurements simultaneously. Instead of searching for patterns by eye, artificial intelligence analyzed recurring dimensions, repeated angles, and proportional relationships across dozens of surviving blocks. The software identified subtle symmetries that had remained hidden for generations, revealing consistent design rules even where erosion had worn away edges or broken entire corners. In some cases, the algorithms could estimate missing sections by comparing damaged stones with better preserved examples elsewhere in the site. These digital predictions provided researchers with new insights into the monument's original appearance, while reinforcing the growing evidence that Puma Punku followed a carefully standardized architectural plan rather than an improvised construction process. Together, these technological breakthroughs have transformed the study of Puma Punku. Instead of relying primarily on speculation, archaeologists can now test structural theories, compare measurements, evaluate architectural layouts, and reconstruct missing sections with measurable accuracy. The monument is no longer understood simply as a collection of mysterious ruins, but as the surviving remains of an exceptionally sophisticated engineering project whose design principles can be studied, modeled, and verified. Every digital reconstruction reveals another layer of planning hidden within the scattered stones, demonstrating that the remarkable precision visible today was almost certainly the product of careful measurement, repeated design standards, and highly organized construction methods. Perhaps the most remarkable achievement of all is that Puma Punku is slowly being rebuilt, not with cranes, chisels, or stone, but with data. Every laser scan, every drone photograph, every computer model, and every digital simulation restores another piece of a monument that has remained incomplete for centuries. As these virtual reconstructions continue to improve, researchers are offering the world its clearest glimpse yet of how Puma Punku may once have stood in all its original grandeur. Although many questions about its builders and its history remain unanswered, the monument itself is beginning to speak again, revealing its secrets through technology that its ancient architects could never have imagined, yet whose extraordinary craftsmanship continues to challenge even the most advanced engineering of the modern age. Material secrets. As remarkable as Puma Punku's engineering appears, the greatest surprise was waiting inside the stones themselves. For generations, archaeologists naturally assumed that every block had been painstakingly carved from solid rock using the best tools available to the Tiwanaku civilization. It seemed like the only reasonable explanation. Yet as laboratory technology advanced, researchers realized that answering one of Puma Punku's oldest mysteries required looking far beyond the visible surface. Instead of measuring joints or reconstructing broken walls, scientists began investigating the microscopic composition of the stones themselves. What they discovered sparked one of the most controversial debates in modern archaeology. The rocks were no longer viewed simply as building materials. They had become archaeological evidence, preserving a chemical record of how they may have been created. The first clue came from the monument's unusual choice of materials. Puma Punku was not built from a single type of stone. Its enormous foundation consists primarily of massive red sandstone blocks, while many of the famous H-shaped architectural elements were carved from dense volcanic andesite. Both rocks present enormous engineering challenges. Andesite, in particular, is an exceptionally hard volcanic stone that remains difficult to shape even with modern cutting equipment. Yet many of the surviving blocks display remarkably flat surfaces, sharply defined edges, perfectly aligned grooves, and extraordinarily consistent dimensions. These observations have led researchers to ask an important question. Were ancient craftsmen simply capable of achieving an extraordinary level of precision through skilled stoneworking? Or could they have employed construction techniques that archaeologists do not yet fully understand? One of the most debated ideas is known as the geopolymer or cast stone hypothesis. According to some researchers, at least certain blocks may not have been carved entirely from solid rock, but instead formed from a mineral-based material that hardened over time. Supporters of this proposal point to laboratory studies reporting unusual chemical signatures within some sandstone samples. Among the substances discussed are traces of sodium carbonate, commonly known as natron, a naturally occurring mineral historically used in a variety of ancient processes, including Egyptian mummification and certain mortar preparations. Because natron can participate in chemical reactions that bind mineral particles together under the right conditions, proponents suggest that it could have played a role in creating a stone-like material through a process known as geopolymerization. If correct, the builders may have worked with a moldable mineral mixture before it hardened into blocks resembling natural sandstone. Although this remains a disputed interpretation, it has encouraged researchers to reconsider assumptions about ancient construction technologies. To investigate the possibility, experimental teams attempted to reproduce similar materials in controlled laboratory conditions. Using mixtures of local sand, volcanic ash, silicate-rich minerals, water, and sodium carbonate, researchers produced hardened samples whose appearance and physical properties resembled certain stones found at Puma Punku. Under X-ray diffraction and other analytical techniques, some experimental materials displayed chemical characteristics similar to those reported in published studies of archaeological samples. These findings do not prove that Puma Punku was built using cast stone, but they demonstrate that such materials can, under controlled conditions, resemble naturally occurring rock surprisingly closely. Whether that similarity reflects ancient manufacturing or merely coincidental chemistry remains one of the central questions under investigation.